Okay, pre-calc, so partial fraction decomposition case number 3, and remember this will be irreducible quadratic, so we're going to have something of the form ax squared plus bx plus c as one of our denominators when we do our partial fraction decomposition. Okay, now none of the steps have changed. We're just going to have to rewrite, make again one alteration based on the fact that we have an irreducible quadratic, and that is because the denominators are now going to have a higher degree. So if your denominator has a higher degree, we need to allow for an x term in the numerator, meaning the numerator also has to have a higher degree. So instead of just saying a, b, or c in one of those, we could have an ax plus b or a bx plus c, depending on where it falls in our order of fractions. So looking at an example, what that means, you'll see here that we have two already factored terms in our denominator. Okay, this x squared plus 2x plus 4 is irreducible, so we can't factor that anymore. One way to check that if you're not sure if something is irreducible is do the whole b squared minus 4ac, and if you get a negative number or something other than 0, really, it is irreducible, or a negative number. Okay, so since we have two denominators here, two factors in our denominator, I'm going to write two fractions, because that's how our answer is going to turn out. One of them is x minus 2, and the other is x squared plus 2x plus 4. And now this is still a linear factor, so it works the same way in the last two cases that we've talked about. We just need to have an a there. On the second one, since we have an irreducible quadratic, it's not going to be just b, because b could also have an x with it, or we could also have a constant. So we're going to write it as bx plus c. From here, our steps are exactly the same as we've done before. We're going to multiply by our lowest common denominator, which is just the denominator. So on the left side, we're going to end up with 3x squared plus 17x plus 14. On the right side, our x minus 2's would cancel out when I multiply by that. So I'd have a times x squared plus 2x plus 4, plus on the second term, the x squared plus 2x plus 4 cancels out. And make sure we're using parentheses appropriately. We're going to have bx plus c in parentheses, and times we'd have an x minus 2 left over. And now the common mistake here is we do not multiply or FOIL correctly when we do this one. The left side is going to remain unchanged. So 3x squared plus 17x plus 14. Distribute my a, so ax squared plus 2ax plus 4a. And then I need to FOIL this piece, so I'd end up with bx squared minus 2bx when I distribute the bx twice, plus cx minus 2c. And from here it is again just like the last one we did, so we need to equate coefficients. We're going to make a system and then use a matrix to solve that system to figure out what a, b, and c are. So if I look at my x squared terms, my equation would be the coefficient on the left side, 3, and then a plus b, because we only have an a and a b on that side. If I look at my x terms, I'm going to have 17 on the left side, and then we have a 2a minus a 2b plus c, because we have a 2ax, a minus 2bx, and a plus cx. And then finally, your last one, your constants, we have 14 equals, and we have 4a minus 2c. And if I cross those out, everything is accounted for. And so I can create my matrix. Okay, now, also be careful here. We're going to have an a, b, and a c column. So 1, 1, 0, and then also we have our constant column, which will be 3 here. And then we're going to have 2, negative 2, 1, and 17 for that second equation. Third equation, 4. Don't get caught up here. B is 0 because there is no b term. Negative 2 for c, and 14. And if we plug that into our calculators and simplify, we are going to get values for a, b, and c. And the value for a is going to be equal to 5. So we'd have a is 5. B is negative 2, and C is 3. So we're going to write our answers. A, 5 over x minus 2, plus, and then our second one is that irreducible quadratic again. And we need to write it as bx plus c. So this would be your partial fraction decomposition case 3 for irreducible non-repeated quadratics. And that is it for this lesson. We'll see you next time.